Hello, everybody. Okay, good afternoon. So we're done with the array lecture. So we're moving on to the next. We're moving on to the next topic in the course. So this is on the next set of slides. So this is char and string. All right. So Java has its own special string type, right? Unlike C. C sort of has a string type, right? C's got an array of char. And then you've got this funny null terminator to end this string. Java has an actual string type. And the Java's string type is capable of doing a lot of things. So many more things than you can do with just the string header file in C. Right? So just like C, the characters of a string, they're made up of chars, right? Individual char elements. String literal is just something in between double quotes, right? So here we have a string rub-a-dub-dub, right? So in Java, that makes a string object. The contents of the string are rub-a-dub-dub, right? And then writing string s equals that object really means that string s stores a reference, or sorry, s stores a reference to the string object whose characters are rub-a-dub-dub. Right? Let me just make a quick edit to this slide. Do the following. String t equals s. Right, and I'll explain what that does in just a second. All right, here. So we have one string here, one string object. Its value is rub-a-dub-dub, right? So s is a reference to that string object. If you write t equals s, then what that does in Java is it says that t refers to the same string that s does. Right? So t is also the string rub-a-dub-dub, right? It refers to the same string object, right? So in this example here, there's one string object, right? Whatever object represents rub-a-dub-dub. There's two variables, right? S and t. They both refer to the same object. So in C, this would be like if you had written char star t equals s, right? So in other words, it's as if you'd taken another pointer and make it point to the same array that s points to. Right? You don't have two separate arrays in C. You have one array. You've got two pointers pointing at the same array. Right? So in Java, I have one string object, two variables that point to the same object. Okay, so in C, to get an individual character out of the string, you would just use array indexing. Right? In Java, the string, you can't use the square brackets to do indexing. Right? Java still considers the string to be a sequence of characters. But in order to get a character out of the string, you have to use charAt. Right? So there's a method called charAt. Right? So name of the string, dot, charAt, and then what looks like a function or a method call. Right? So the 0 here, that's the index of the character that you want to get. Right? So that'll give you back the r in this case. Right? 1 will be the index of the second character. The last character in the string, right, is the length of the string. The index would be the length of the string minus 1. And I'll explain how to get the length of a string in a moment. Okay, so yes, question.
What will it give you if you call, like, say, the length of the string instead of like -1?
So if you wrote s_char_at s.length, you would get an exception. So in Java, you get an error, right? In C, if you try to access one of the elements that don't exist, it may or may not work, right? Java, you always get an error. Yeah. Okay, so the individual chars. The individual characters of the string, those are just chars, right? A char literal is a character that you can write down, right? So just like in C, you write a char literal inside of single quotes, right? You can write the space, right, as a char literal. There's no such thing as the empty char literal, right? So you can't write single quote, single quote. You can't do that in C either. It doesn't work. Right? So there's no such thing as the null char literal, for example, right? Or null char. Right? So there has to be a character in between, one character in between the single quotes. There can be more than one, but if you're putting in more than one, then you're putting in some sort of special character. And I think I'll explain how to do that in a later slide. Okay, so just like in C, char is actually an int. Right? I don't know if they told you that in C, but C in both languages, char is an integer value. Right? In Java, C doesn't actually say what the char value is. So it doesn't actually say how do you take that integer value and map it to a printable character. The standard says it's up to the compiler to determine that. Java says that we're going to use this thing called Unicode. So Unicode is a standard that's meant to be able to, you can write down any character, any written character in the entire world, right? So that's the intent. It also includes other things like mathematical symbols, emojis, a bunch of graphics characters and things like that. Right? So in Java, the smallest char value is 0. The largest char value is 2 to the 16 minus 1. 2 to the 16 minus 1, 65,535. Right? Now, I'm doing something funny here. Right? So just like with ints, right, the min value and max value, those are stored in a class called character. Right? So big C, character. Why it's not big C char, I don't know, because it's the class that represents information about chars. Right? They decided to call it big C character, so that's what we're stuck with. Right? Notice that when I print this thing out, right, I'm actually casting it to an int. Right? So on this line of code, I take the character, the char value, cast it to an int, and it would print 0. Right? If I take this value, cast it to an int, it would print 65,535. Right? If you don't cast the value, then println will try to print the character corresponding to that and that. Right? So the character corresponding to 0 is a blank, and the character corresponding to max value, I have no idea what that is. It's some funny character. If you actually tried to print it in Eclipse or in Visual Studio Code, you'd probably get you'd either get a funny symbol or like a square, a solid square or something like that. Yes?
If you entered a integer larger than 65,535, would you get an error, or would you get like the remainder?
So if I passed in a value here?
Well, if you passed in like char c equals 60,000.
Ah, I see. So that will, I believe the answer is that doesn't work because it doesn't fit into char, but I haven't actually tried. But I believe the answer is it won't work. It won't wrap around, in other words. Okay. So if I set C to 65, it turns out that's the uppercase A. Right? So if I print that out as a char, you get the uppercase A. If I cast that value to an int, you get 65. Right? Now, you can do arithmetic with chars. So I can add 25 to C. Right? So that'll give you, what, like 90, right? So there's 26 letters in the alphabet. So not surprisingly, if I start at the A and add 25 to it, you end up at the Z. Right? So this gives you a way to loop over the letters of the alphabet, for example. Right? You could write a loop starting at char C equals 65. Right? And then update C by 1 each time in the loop and print out each letter in the alphabet. Right? Okay, so you can do arithmetic with char because, well, it's just an integer. Unfortunately, the results are unintuitive, especially when int values are involved. So it's a little bit weird how this works in Java, and I'm not exactly sure what the rules are in C. I do know what the rules are in Java. All right, so let's start with A. Right? If I write C++, that's fine. Right? That will actually add 1 to A, and if you print it, it'll give you B. Right? If I write C plus equals 1, that's also fine. It'll add 1 to the B, and you'll get C. Right? C minus equals 1 also works. Right? Subtract 1 from C to get B. What doesn't work is the next line, which is super confusing, especially when you see it the first time, and if no one's there to explain it to you. Right? So if I write C equals C plus 1, that looks like it ought to work, because that is effectively the same as that and that. Right? That's probably what you were told at some point in the past. Right? You're probably told C equals C plus 1 is equivalent to C plus plus, or plus plus C, or C plus equals 1. It turns out that's not exactly true in C or Java or C++. They're actually different operators. Right? So that operator is different than that, which is different than this expression here. And so the rules for the different operators, you have to look up what they are exactly for the language that you're working in. So what happens here in Java? So the way, when you write something, x plus y in Java, what Java does is it says, what is the type of x? What is the type of y? Can I add these two things together? Right? So here we have char. Here we have int. So Java asks, can I add these two things together? The answer is yes, but it has to convert char to int, because int is the wider type, right? It holds a wider range of values than char. So the rule is in Java, if you take if you try to add two different types, values from two different types, then smaller type gets promoted to the wider type. So char gets promoted to int, right? So this c becomes a 65. Plus 1 is 66, but that's an int, right? Now, can you store an int in a char in Java? And the answer is no, you can't. You can in C, I'm pretty sure. In Java, you can't. So if I try to store a char in an int in a char in Java, the compiler complains, right? It says that the int value is too wide for the variable you're trying to store it in, right? And you say, well, that's really bizarre because these ones back here worked, right? So plus equals 1 and plus plus, they all worked. And the reason they work is because they are defined specifically for the type char, right? So in other words, if you look at the language standard for Java, it says if you write C++ and C is a char, then this is the way it works. If you write C plus equals something and C is a char, this is the way it works. Right? Here, it falls back on its arithmetic rules. Right? If I add two different types together, promote the narrower type to the wider type, the result is the wider type. Right? So that's weird. Right? But now you know why it doesn't work. It gets even weirder. So if I start out with another char, right? So I make char d, and that's equal to b, right? Can I add c and d together? Right? And you say, well, you just told me if I write x plus y, then it looks at the types and it tries to determine what the type of the sum is. And that's true, right? So I have a char plus a char. The problem is in Java, the language says if you try to do arithmetic with any type narrower than int, the values get promoted to int, right? So even if you have two chars, they both get promoted to int. The result's an int, and you can't store an int in a char. Right? Why does it work that way? I have no idea. That's just the way the language designers decided to implement the language. My suspicion, although I don't know if this is true, is because that's also the way it works in C. I don't actually know definitively, though, why it works that way. Right? It works that way. You have to get used to it. Right? So be very careful when you're trying to do arithmetic with char. So why would you want to do it? Well, here's an example of why you'd want to do it. Right? I can write loops using chars as my loop variables, right? So I can generate all pairs of two uppercase letters with a nested loop, right? So I start, my character C starts at A, goes up to and includes Z, right? My character D starts at the A, goes up to and includes Z, right? And then I'm just going to concatenate the two characters together. Notice how I do it though, right? I start it with a string, right? So this is something plus something plus something. So Java goes left to right because all the operators have the same precedence. So string plus char, Java converts the char to a string, and it does string concatenation to give you a string. String plus char, Java does string concatenation to give you back a string. Right? So that actually produces AA, AB, AC, AD, and so on up to ZZ. Yes?
If you declare the reference type like string,
Yep.
you still need the double quotes.
The double, sorry, if I declare what as?
String S.
Yeah.
So you declared it's a string.
Yeah.
You still need those double quotes. Like what's
The double quotes here is to make sure this sum doesn't get computed as an integer sum. It's to make sure this gets done as string concatenation. So empty string plus, so if I get rid of the empty string, then it's char plus char, which gives you an int, right? And then you get an error because you can't store an int in a string. So you have to append some sort of string to everything. If you're going to do this thing, make sure the empty string's at the front and not at the end, right? If you put it at the end, then the stuff at the front might be summed the wrong way, right? So if you want to do string concatenation, make sure the empty string appears at the front. All right, any other questions? Otherwise, there's not a whole lot of use for, well, I can't think of a whole lot of other uses for doing arithmetic with char. Yeah.
Well, you said that like a couple slides back you had chars being cast as ints. Can you do it the other way, like do the operations as integers?
Yes, and cast it back to char? Yes, that works. Yes. Any other questions? Yes.
Why would you do it this way? Like what situation?
Why would I do
The quote.
here?
Yeah.
Because I want to make a string, right? I want to make the string AA, then the string AB, then the string AC, and so on and so on and so forth. Yeah. Any other questions? All right. Okay, types, classes, and objects. So we're starting to, because string is actually, so string's a class, strings are objects, right? And so now I have to tell you precisely what do I mean by these things, types, classes, and objects, right? So a type is just a set of values and the operations that you can do with those values, right? So int is a type, right? What are the set of values? Well, integer min value through integer max value. What can I do with ints? Well, I can do arithmetic, right? I can compare them and things like that, right? So that's what a type is. A class is just a reference type in Java, right? So string, for example, is a class, right? You can make your own classes. So what that means is you can make your own types in Java, right? And they can do all sorts of things, right? Whatever you want them to do. Okay, now what's an object, right? So if string is a class, right? When I talk about a string object, right? That's just what we call an instance of the class, right? So it's a thing, right? An entity, right? Whose type happens to be whatever class its type is, right? So a string object is just a thing whose type is string, right? What's inside the thing? Well, there's some data, right? And what can it do? Well, it's got some methods that you can apply to the object. So the operations that you can do with an object are the methods that you can run on the object. So string represents text, right? So it's a sequence of characters. Turns out it's very widely used in many Java programs. So it's considered a fundamental part of the Java language. Now because it's considered a fundamental part of the language designers went out of their way to make string, to give string abilities that you can't do with any other kinds of objects. So string's a bit weird. It's normally the first object that you encounter, but it's also the most unusual object that you can encounter, because you can do stuff with strings that you can't do with any other objects, right? So for example, there are string literals. There's no other literals for any other type in Java, right? Any other reference type, sorry, in Java. The plus operator is defined for strings, right? So I can do string concatenation, but there are no other operators defined for any other reference type in Java, right? So string's a bit odd. You can find the documentation by clicking on that link or just Googling it, right? I'm not going to look at it right now because I haven't really shown you how to read a piece of Java documentation yet, but we'll get there shortly. All right, so in C, you know that a string is just an array of char, right? So if you wanted to, you can go into that array and change the characters, right? Go in and change the first character to be the uppercase A, for example, right? You can't do that in Java, right? So strings in Java are immutable, right? What that means is that once you make a string object, right, the characters in that object can never change, right? And you might think, well, that sucks, right? Your string class doesn't seem so useful anymore, right? Because I can't change the characters, right? But it turns out the Java language designers made this decision for a good reason, right? Methods that seem like they change the characters of a string, they don't change the characters of the string. What they do is they return a reference to a new string object, right? So there's lots of methods in the string class. They look like they modify the string that you used to call the method with. They don't, right? So for example, there's this method called toUpperCase and toLowerCase, right? And they do kind of what you expect them to do, right? You take a string, you call toUpperCase, and it gives you the uppercase version of the string, right? So right here, right, I've got the string hello, right? S is a reference to the string hello, right? If I want to use the toUpperCase method, I need a reference to a string object, right? So in other words, I need S, right? So I can write S dot toUpperCase, right? And that returns the uppercase version of hello, right? So big H, big E, big L, big L, big O, right? What it doesn't do is it doesn't change the original string, right? So if I print the value of S, you get lowercase hello, right? If you print up, you get the uppercase version of hello, right? Because up is a reference to the string that was returned by toUpperCase. Right? So methods that appear to change the state of a string don't. Right? So what does that mean? So what that means is if you want the uppercase version of a string, you can't write the following. Right? So this is a very common error made by people new to the Java language. Right? They look at this method and say, oh, it gives me the uppercase version of the string. So I write s to uppercase, right? Thinking that the original string changes, right? It doesn't. So what does this do? Well, it calls to uppercase on hello, right? Makes the string big H, big E, big L, big L, big O. Returns it to the caller, but the caller doesn't keep a variable to it, right? So that variable, the uppercase version of hello disappears, right? It goes out into the ether somewhere, right? And you don't have access to it anymore, right? Now when you go to use s, it's still lowercase hello, right? There is no up anymore, so that line wouldn't work anyway, right? So that's a very common error, right? Avoid doing that, right? Instead, if you call the string method, make sure to get the return value because you almost certainly want it for some reason. Oh, wait, I screwed that up. That's not t, that's up. Okay, so you require an object reference to call a non-static method, right? So remember everything that we've done so far, I've told you, well, all our methods are going to be static, right? So toUpperCase and toLowerCase, these are the first instances where you've seen what's called a non-static method or just a method, right? So normally when people say method in Java, they mean non-static method, right? So if you have what's called if you have a regular method in Java, you need an object reference to call the method, right? So here, to call toUpperCase, I need some variable that stores a reference to a string object, right? So when you write s.toUpperCase, what you're doing is, right, I'm using the object referred to by s to call a method, right? So in other words, I'm asking s, what is the uppercase version of your string, right? So that's how you should think about it. So when you use s.some method or x.some method, you're asking the object x to run that method probably with the data belonging to that object, right? So here we get the uppercase string hello, right? Why? Because s was originally the lowercase version, the lowercase string hello. Okay, string has static methods as well, right? If you want to call a static method in the string class, then you just call it using the name string, right? So there's this method called value of in the string class, which is static, right? Value of, in this case, will take in, accepts a double value, right? So in this case 1.0, and returns the string that corresponds to the double value 1.0. Right? So in other words, this returns the string, double quotes, 1.0, probably. Right? So you can call the static method to get you can call value of for any primitive value that you want to get the string representation of that primitive value. Right? You almost never do that because it's almost always easier to use concatenation. Right? So that is functionally equivalent to that. Right? Take the empty string and just append whatever the string representation of 1.0 is. Right? How does this work? Underneath the hood, the compiler actually calls value of on the 1.0 and then concatenates it with the empty string. Right? So you don't have to call value of yourself, but that's an example of a static method in the string class. Right? So strings got both static and non-static methods. Right? If you want to call the static method, use the name string. If you want to call a non-static method, use a variable or an object reference. Yes?
What's the difference between using just, instead of writing hello, just 1.0 and the quotation marks?
Instead of writing
There's quotation marks plus 1.0.
here,
What's the difference between just putting quotation marks and 1.0?
you could also quote the 1.0 if you wanted to.
Okay.
Yeah, if you wanted to. But if imagine this 1.0 was actually a double variable. So if it was x, right? You wouldn't double quote the x, right? You would write empty string plus x.
So this is more just a
Example.
Instead of 1.0 should just be whatever you're dealing with.
Yes.
Okay.
Yep. So I guess let's more precise. Let's actually write that out. Right. So double x equals 1.0. Right. And now this becomes x, and this becomes x. And that is arguably a better example. Right? Yes?
And doing that's still going to make your string be the number 1.0.
Yep, in this case, yes. Of course, if you change the value of x, then it won't be. Yeah. I'm pretty sure it's 1.0, the string. You'll understand why I say I'm pretty sure in a couple of lectures from now. Floating point values are weird. Yes?
So that prints like the number 1.0, not like the ASCII character.
Not the ASCII.
Like you said earlier, like
Yeah.
65
Yeah.
is an A.
Yeah, but that's because so if you have a char, right? If you have a char value, right, and you print it as a char value, then you get the printable value. So you get the A, right? If you take that char value and cast it to an int, then you get the integer number 65. Here, it's a double value, so you always get whatever the string representation of that is. Yeah. Another question? I thought I saw a hand. Yes?
It's just a string now.
This is
Like
just a
T,
string.
sorry.
T is a string. Yes, T is a reference to a string. That's right. Yeah. It's easy to tell because the type for T is right beside it.
Okay.
Yeah. And remember, when you make a variable in Java, the type can't change. Right. Any other questions? All right. Okay. What if I want to test if two strings are equal? Okay. So if you want to test if two ints are equal in Java, you use equals equals, right? If you want to test if two anything are equal in C, you use equals equals or exclamation mark equals, right? Not equals. Probably one of the hardest things to remember in Java is that you want to avoid equals equals and not equals if you're dealing with reference types. Most of the time, almost all of the time, right? So if you want to test are two reference type things equal, right? Don't use equals equals or not equals. The problem with string is that it works most of the time, or seems to work most of the time, until it doesn't, and then you run into a problem. Right? So string, again, it's the first class you see, it's the weirdest class you'll ever see. Right? Okay, so I want to test if two strings are equals, use what's called the equals method to test if they are equal. Right? So they represent the same sequence of characters. Right? So here, I've got the string hello. Right? Here I'm doing something strange, right? I'm writing new string hello, right? What does that do? Well, it actually makes a new string object whose contents are HELLO, right? We're going to see this new construct over and over and over again in this course, right? Okay, now I want to test is S and T, right? Are they equal? So in other words, do they represent do S and T both point to objects whose value are H, E, L, L, and O, right? So if I want to test that, right, that's when you write S dot equals T, or T dot equals S would also work in this case, right? So are the strings S and T equal, right? Do they have the same sequence of characters, right? This is the same thing as string CMP. Well, sorry, it would be analogous to string CMP in string CMP in C, right? Compared to strings. Right? The result of equals is always true or false, right? So you always store the result in a Boolean variable, right? The next line here is here. So this is the thing. Okay. So I want to test. Do they have the same sequence of characters, right? So if I write S equals T, and then print out the value of boo, you'll get true. On the next line, this is where I use equals equals. Right? So if I write S equals equals T in this case, the result is false, right, in this case. Question, and then I'll explain why.
Can we use the equal, actually I've mostly seen it used in if statements and otherwise. Do we just use it only for Booleans?
No, so the equals equals, you use it for any primitive type, right? If I want to know if two int values are equal, equals equals, right? I want to know two double values are equal, equals equals, yeah.
I meant more in the, instead of, equal, if you have a thing equal.
Oh, you mean this weird line here?
Yeah.
Yeah, you almost never write that. It's just here because I needed to write that for this slide. Yeah, that's unusual.
That would only mostly be a Boolean thing?
Yes, normally you want the condition, you want to use the condition for some reason. Yes, that's a bit unusual. Yes?
Why should you use new in the second line?
So also, let me explain that one after I explain why equals equals returns false here. Okay. Like I said, string is a weird class. Okay. All right, so s equals t. So I told you what equals does. If for two strings, equals compares the characters in both strings, right? So if the lengths of the both strings are the same and the characters in the corresponding positions are the same, equals returns true. Otherwise, it returns false. Now, what does equals equals do? Okay, so for primitive values, equals equals does what you want it to do, right? It compares the two values. If they're the same, you get true. If the two values are different, you get false. Right? So in other words, it does what you intuitively want it to do. Now, what does equals equals do if you have a reference s and a reference t? Right? So equals equals always tests the value of the variable. Right? What is the value of a reference variable? Right? So the value of a reference variable is the memory address of an object in Java. Right? More or less. Right? So this is actually asking, is the memory address of s, is the memory address of the object that s refers to the same as the memory address that t refers to? Right? In other words, this is basically asking, are s and t the same pointer in C? Right? So does s refers to that object there? T refers to a second object here. So no, they don't refer to the same object, which is why equals equals returns false in this case. Right? Because s refers to a different object than t refers to. Right? Okay, now the question here, why did I have to write new string hello? Right? And so the answer is because if I didn't, this slide wouldn't work. So that's why. String t equals hello. Okay, now what happens? Right? So turns out if you write the following program, right, that will be true, and now this will be true. Right? And you say, well, what's going on here? Right? So the rule is, in Java, if you have a string literal in your program somewhere, like hello, right, then the string class will try to remember, hey, they've used a string literal hello. If you use it again, the string class will say, hey, they've already used a string literal hello, I'm just going to reuse that string literal. Right? So in other words, here, you only have one object whose value is hello, even though you wrote hello twice inside of brackets. Right? The string class tries to be smart. It tries to save memory. Right? Instead of making two objects that are both hello, it makes one. Right? And it gives you a reference to that one object. Right? So in this case, s and t both refer to the same object, which is also super confusing when you see it for the first time, the second time, and probably the 10th time. Right? It's just the way the string class works. Yes?
Is it only string class that functions?
No, it's not only the string class that works this way. So int, its corresponding object type is integer, right? For double, little d double, the corresponding type is big D double, right? For character, the corresponding type, for char, the corresponding type is big C character, right? It turns out you can write something like the following. Integer j equals 1, integer k equals 1. Oh, I said there's no literals. I guess I lied. All the classes that correspond to a primitive type, they have literals as well. It's not true. So there aren't literals. Okay, so this code here, right? You shouldn't write this. You should write int j and int k equals 1. If you write this, what ends up happening is the compiler looks at that 1 and turns it, makes an integer object, right? Because this is j is supposed to be a reference to an integer object. So it takes the 1, makes an integer object equal to 1, and it gives you back the reference to that object, right? The integer class works the same way as the string class. If you use another int literal somewhere and you turn it into an integer object, it remembers that you used that literal at some point, right? So in other words, is that exactly? I'm pretty sure that's how it works, right? So if you do this twice, then you end up with one integer object whose value happens to be 1, and you get back a reference to the same object. So these are called the wrapper classes because they wrap a primitive value. They also work this way. But that 1 is not an integer literal, right? It's an int literal that gets converted to an integer object. Right? This is all getting into the weeds of the actual specifications of the Java language, which we're not really concerned with. The take-home message from this slide is, right, let me put this back to the way it was. The take-home message from the slide is supposed to be, if you have two strings and you want to test if they're equals, use equals, right? Do not use equals equals. Okay, question? Yeah.
Because this is like essentially a pointer for, well, not essentially a pointer.
You can think of it, yes, as a C programmer, it makes sense to think of references as being pointers.
How would you pointer to pointer?
You can't in Java.
Okay.
So can you get a point? Yeah, so that you can't get a reference to a reference in Java. That doesn't work. Yes?
So just to confirm, in order to
Yeah.
save space, it's saving to the same address.
It's remembering that there's another object that happens to have the value that you want.
Okay.
So in effect, what it's doing is keeping two pointers to the same object. Right? Yeah. Yes?
For the strings, like it doesn't seem like an issue since you can't modify them.
That's right. That's why they do it this way. It's because you can't modify them.
But what about for like integers?
Can't modify an integer either. No. You can modify an int. Can't modify an integer. So once you make the integer object whose value is 1, there is an integer object whose value is 1 somewhere. I can reassign it here. I can write j equals 2. That's fine. But I'm not changing the underlying integer object. Yeah. Again, all this is getting into the weeds of the language. It's not really that, like it's not, I'm not going to test you on any of this. Yeah. But it's good that you're asking these questions. Okay. All right, so string is just a numbered sequence, right? So you know that, a string in C is just a char array. So you can think of a Java string as being the same thing. It's just you can't access the elements in the same way, right? So the strings CISC124 or CMPE212, they would be strings of length 7, right? Index 0 is the first, index 6 is the last. The number of characters in a string is called its length. Right? So in Java, in C, you would use strlen, right, to get the length of a string. In Java, you just take the variable and write dot length, round bracket, right? And away you go, right? So Java strings are not null terminated, right? So there's no extra character on the end of this string. Right? So length of a string is easy. Every string knows how long it is. You just ask it for its length, right? Dot length. That's why this is called object. That's why the language is called object-oriented programming, right? You're asking objects for information, right? The way you ask them for information is to call a method, right? So I want to ask course name, hey, how long are you? Well, it tells you it's 7, right? The empty string has length 0, right? Obviously, length is never less than 0. charAt gives you the character at a specified index, right? So 0 is the first. The length of the string minus 1 is the last. Right? So if you want to write a loop over the characters of a string, start at 0, right? Go up to, but not including, the length of the string. Right? Each time in the loop, ask the string for the character at I, and then do something with the character. Here I'm just printing it out. You might do something else, right? If you're doing some sort of string processing. This is an example of processing a string to count how many times a specified character appears in the string. Right? So here's a method called freq, so frequency. Right? It takes in a string, and it takes in a target character. So this method counts how many times does the target character appear in S. Right? So this is just a simple counting problem. Right? Start with a count of 0, loop over the elements of the string. Right? So start with a loop. Starting at 0, up to but not including the length of the string, right? Get the character at index I, and test is it equal to the target. Here I can use equals equals, because target is a char, and charAt returns a char, right? They're both primitive values. So here equals equals is the appropriate thing to use, right? If I find target in the string, count goes up by 1. At the end, return the count. And away you go. And this is how you'd use the frequency method. Right? So there's my string. How many times does the C appear in CMPE212? 1, not 2. Right? This used to be CISC124. That's why there's a 2 here. So that's 1. 1. I bet you are the other ones right? 2. No, the other ones are okay. Right? Characters are case sensitive, right? So lowercase c is not the same as uppercase C, right? So if you ask how many times does the lowercase c appear in there, answer 0, right? How many times does the 2 appear in here, right? Notice that's 2 as a literal, right? Not 2 as an int, right? So it's the char 2, so it's inside single quotes, right? And of course you get 2. There's a contains method in the string class. So contains returns true if a string contains a specified substring. It's str in C if you want the substring method, right? So here I've got the string CMPE212. I would like to know, does that string contain the string CMPE, right? Obviously the answer is yes. Does it contain lowercase CMPE? The answer is no. Does it contain a 1? Yes, right? Can you search for a char using contains? So the answer is no, not using contains, right? So I can't search for a single character. But you can play a trick. You just turn that character into a string, right? How do I turn the character into a string? Well, I append it to the empty string, right? And now that works, right? So contains, unfortunately, doesn't have a version where you can test for a char. Yes? You can, but if again, if I have a char variable instead, you have to convert it to you have to convert it to a string. What time is it? We got not quite time. Some of us have to head over to Jeffrey for the lab after this. So, okay, index of returns the first location of a specified character in a string, right? So index of will tell you where is the first C in the string CMPE212. Right? So the first C obviously is the first character, so that's the index 0. Right? What is the index of the P? Well, it's 0, 1, 2. The first 2 would be at index 4. Right? If the character does not appear in the string, you get back -1. Right? So you could also use index of to test if a character is contained in a string. Right? Just check if index of returns a value that's 0 or greater, right? And that'll tell you if a character appears in a string or not. And finally, I think this will be the last one, because I have to walk over to Jeffrey too. Last index of will tell you the index of the last character in a string, right? Returns -1 if the character is not in a string. So where's the last C? Well, there's only 1, so it returns 0. Where's the last P? There's only 1, so it returns 2. Where's the last 2? Well, it returns the index of that one there, right? So that's 6. Where's the last Z? Well, it's not there, so you get back -1. And anything else? Oh, equals, right. So again, equals, use equals if you want to test if two strings are equal, right? In both this course and in CISC 124, even on the exam, there's still students using equals to compare strings, right? Remember now, if you want to compare strings for equality, use equals, right? It doesn't make sense to lose marks on the exam because you're using equals. All right, those of you in the lab, I'll see you over in Jeffrey. Everybody else, I'll see you in, I don't know, tomorrow or the next day, I don't remember.